Welcome to this video. In this video, we are going to discuss about the F distribution. It is used to test whether the population variances are equal or not. The other name for F distribution is, or F test is, variance ratio test. Here, first we discuss some properties based on this. The F distribution is positively skewed and its skewness decreases with increases in mu1 and mu2. Here we consider two samples, the corresponding size are n1 and n2. The corresponding population variance are sigma 1 and sigma 2. And the corresponding degrees of freedom also for the first sample is mu1 and second sample is mu2. The F distribution always lies between 0 to infinity. The mean of F distribution is mu2 divided by mu2 minus 2. Here mu2 is greater than 2. The variance of F distribution is 2 mu2 square of mu1 plus mu2 minus 2 and mu1 of mu2 1 minus 2 the whole square, mu2 minus 4, and here mu2 is greater than 4. The shape of the F distribution always depends on the number of degrees of freedom. Uses of F distribution. It is used to test the equality of two variances from which two samples have been drawn. Remark for this one, in the test statistic, greater than the two variances S1 square and S2 square is to be taken in the numerator and denominator corresponds to the greater variance. Okay, depends upon the value of S1 square and S2 square. Always the numerator is greater than the denominator. Depends on that we can choose S1 square for numerator or S2 square for numerator. And F test has been already prepared. Tables are available that give different values for nu1 and nu2 for 5% level or 1% level of significance. We extract from these values from the table is given at the end of this chapter. Note, to test whether two independent samples have been drawn from this sample same population, we have to test equality of the population means we can use t-test. Equality of the population variance means we can use f-test. That is, we are going to test whether the equality of the population of mean means we can use t-test. Population of variance means we are going to apply f-test. Since t-test assumes sigma 1 square is equal to sigma 2 square, we first apply f-test and then t-test. Okay, this test is used to test the significance between two or more sample estimates of population variances. Okay, f-test is used to find the significance between two or more variances. Consider two independent random samples x1, x2, etc. xn, y1, y2, etc. yn. These are drawn from normal population. Then the hypothesis to be tested is the population variance are equal. Next we formulate the null hypothesis and alternative hypothesis. That is h0 is sigma 1 square is equal to sigma 2 square and h1 is sigma 1 square is not equal to sigma 2 square. Next we choose the level of significance, that is alpha is equal to maybe 5% level or 1% level of significance, and in this test we are going to choose the degrees of freedom is n1 minus 1, n2 minus 1. n1 is the sample size of our first samples and n2 is our second sample size. Therefore take the differences n1 minus n1 and n2 minus 1 and take the product of these two, we get mu1 and mu2. That is n of mu1 comma mu2. Next we find the test statistic value for f test. Sometimes s1 square divided by s2 square if s1 square is greater than s2 square. Otherwise we can apply the another form s2 square divided by s1 square where s2 square is greater than s1 square. And we use the, if directly s1 square is given means we can apply this formula, or First we have to find the sample standard deviation value S1 and then product with N1 divided by N1 minus 1. Similarly for S2 also. Instead of S1 square, sometimes they are giving some of the squares of their differences are given. X1 minus x1 bar the whole square divided by N1 minus 1, or another one x2 minus x2 bar the whole square divided by N2 minus 1. Okay. This is the way of finding capital S1 and S2 square. If it is S1 is not given, that is a sample standard deviation, small s1 is not given, means we want to compute that small s1 square and s2 square. That is sum of x1 square divided by n1 minus sum of x divided by n1 the whole square. Similarly for s2, sum of x2 square divided by n2 minus sum of x2 divided by n2 the whole square. Next, compare the calculated value of f with tabulated value of f at 5% level or 1% level with the corresponding degrees of freedom, and we conclude that if tabulated value is less than the calculated value, means H0 is rejected, or calculated value is less than the tabulated value, means H0 is accepted. Now we are going to solve some problem based on F test. The data given below are the qualities of 10 items produced by two processes capital A and B. Test whether the variability of quality may be taken to be the same for the two processes. The data given below for the qualities of the products. The process from A, another one is process from B. We want to check the variability of the quality may be taken to be same for the two processes. The variability of the quality may be same or not. Here 10 items are given. Therefore, the sample size is, first we assume let x is equal to quality measures by process A, and we denote by, that is the quality measures by B, by process B. Next we set up the null hypothesis and alternative hypothesis. The null hypothesis is H0. Here the variability of the quality may be taken as the same for the two processes. For H0 is sigma 1 square equal to sigma 2 square. That is, there is no significant difference between their variances. H1 is sigma 1 square is not equal to sigma 2 square. There is some significant difference between them. And we can choose the level of significance. The level of significance is 5% level. Here we want to calculate the data, 10 data are given. From this we want to calculate sigma x, that is sum of the process, sum of the quality of the measures by process A, that is 45, and sum of x square, each term squares, taking squares and then addition of all, we get answer 219. Next, sum of y, taking sum of all the quality measures by process B, sum of y is 58, and then calculate sum of y square, taking squaring of each term and then adding, we get 374. Here we want to calculate small s1 square. That is, small s1 square is our sample variance value. That formula is sum of x1 square divided by n1 minus sum of x1 divided by n1 the whole square. Similarly for S2, sum of x2 square by n2 minus x2 by n2 the whole square. Or you can use, instead of x1 equal to x, x2 equal to y. Therefore, S1 square is equal to sum of x1 square is 219 divided by total number of items 10 minus sum of x 45 divided by 10 the whole square, we get the answer 1.65. Similarly for S2 square, sum of x2 means or y, second variance value S2, or you can use the, instead of the letter x2 is equal to y, 374 divided by 10 minus sum of x2 divided by 10, 58 divided by 10, the whole square is 3.76. Next, calculate the capital S1 square and S2 square. We know the formula for capital S1 square. Next, we want to compute the capital S1 square and S2 square. Okay, that is capital S1 square is equal to n1 into small s1 square divided by n1 minus 1, that is 1.833. Similarly, S2 square is 4.178. Now, calculate the test statistic for F test. Here, comparing S1 and S2, S2 square is greater than S1. Therefore, our numerator is, the greatest value is S2 square 4.178 divided by 1.833. Therefore, test statistics is here S2 square is greater than S1 square. So, we can choose our numerator is greater than the denominator, that is 4.178 divided by 1.833. That answer is 2.28. That is our calculated value of F is 2.28. Okay, next we want to calculate degrees of freedom. Okay, here we have two sample variances are there. So, we want to calculate 2 degrees of freedom, that is mu1 comma mu2. We got it mu1 from this computation n1 minus 1, n2 minus 1. n1 is number of samples. Number of samples is here 10 samples, 10 minus 1, 9. And n2 minus 1 is our second sample size is also 10, 9. Therefore, the degrees of freedom, the coordinates are 9, 9. Okay, now by using table for F chart, for by percentage level, our degrees of freedom, mu1 is also 9, mu2 also 9, 9, 9. The answer is 3.18. Therefore, our tabulated value of F at 5% level is 3.18. Okay, therefore, the tabulated value of F is 3.18. Now, comparing our calculated value of F with our tabulated value of F, so here we conclude that calculated F is less than the tabulated F. Okay, already we know that the calculated value is less than the tabulated value, means we accept H0. So, we accept H0. H0 is sigma 1 square equal to sigma 2 square, that is the variability of the quality, we accept H0, that is the variability of the quality may be taken to be same for the two processes. Second problem, two samples of sizes 9 and 8 give the sum of squares of their deviation with respect to their means equal to 160, 91 respectively. Can the samples be regarded as drawn from the same normal population? First, we list out the given conditions. Here the sample size is N1 is equal to 9, N2 is equal to 8, and sum of the squares of their deviation from their respective means, that is sum of their squares of their deviation, that is sum of x1. First sample is denoted by the letter x1, second sample is denoted by the letter, that is a sample means is denoted by the letter x1 and x2. x1 the whole square, sum of the squares of their deviation x bar the whole square is equal to 160, and sum of x minus, this is x1, this is our x2, x2 the whole square is equal to 91. Now these are the given datas. Now we set up the null hypothesis and alternative hypothesis. Null hypothesis H0, there is no significant difference between them, that is sigma 1 square is equal to sigma 2 square, that is the samples be regarded as drawn from the same normal population. The normal population. H1, that is our alternative hypothesis, which is not equal to, there is mu 1 sigma 1 square is not equal to sigma 2 square. Next we choose the level of significance. Level of significance is 5% level. Level of significance is 5%. Okay, next we want to calculate the test statistic for F test. For that we want to calculate capital S1 square divided by S2 square or S2 square divided by S1 square. That is S1 square equal to sum of x1 minus x1 bar the whole square divided by n1 minus 1, that is 20. S2 square is 13. Next we want to calculate the F statistic. Here comparing these two values, S1 square is greater than the S2, therefore our numerator is S1 square. S1 square divided by S2 square, that is 20 divided by 13. Okay, simplifying that we get the calculated value is 1.5385. Next we want to calculate the degrees of freedom. Our first sample size is 9. Therefore, the corresponding degrees of freedom is 9 minus 1, 8. Our second sample size is 8. The corresponding degrees of freedom is 7. Okay, next, at alpha 5% level of significance, the tabulated value of F is 3.73. For the degrees of freedom 8,7. Now we want to compare the calculated value of F with the tabulated value of F. Here calculated value of F is less than the tabulated value of F. So we accept H0. Our H0 is the samples may be regarded as drawn from the same normal population.